Okay, here we go with compound inequalities. Let me read to you this question instead of writing it all out. Basically, it says here, and there's an example, it says all the real numbers that are greater than or equal to -2. So this is what I do. I usually put all the numbers, which means x, and are greater than, x is all the real, these are real numbers, greater than or equal to 2. So these numbers are all greater than or equal to a -2. And these are also less than 3. So x is less than 3. Okay? That's the example I'm going to give you right now to try. We have to first graph it on a number line, and then we need to write it in a what's called an inequality sentence, I think, a compound inequality sentence. So if you see something like this or read something like this, it's best to read it out loud and set it up where all those numbers is x or y or c or whatever variable you choose to give it. Then I write it down individually. I'm going to rearrange these numbers now into one sentence, where x stands in the middle, because this would mean and. Okay? So x is, and I'm going to use this direction in relationship to that 3, x is greater than, if I read it from the x is, less than 3, right? And if I read it from the x again, x is greater than a -2. Or equal to. Both of these are or equal to. And so if you see this, now you've just written the sentence for this compound inequality. That's half the problem. Now they want you to graph it. So I'm going to put a number line right over here. Okay? I'm going to put 0 here. I'm going to put -1, -2, and I'm going to put 1, 2, and 3. Okay. I know that x is less than 3 or equal to. So I'm going to put a circle around here. I'm going to fill it in. I'm going to use a different color just for our example right now. You don't have to do that. Okay? And then I also know that I'm going to -2 and equals to, so I need to fill in that circle. And I know that x is everything in between here. Okay? So that's how we solve a compound inequality from a sentence or from a paragraph form. We'll try another one in a second. Okay, here's the second example. In the second example, is you're supposed to draw this inequality or solve the compound inequality with this or and in the middle, and we'll figure out how that works out. I guess this is an and we'll see what that shows like. So in this case, the first thing we want to do is we want to get the numbers that are in the middle right now. See this area right here? We want to get rid of this number right here, this number 6. We want to get it out of here. But we have this, obviously, this minus x interacts with the right-hand side of the problem and the left-hand side of the problem. So in order to get rid of that, we need to treat this as two different problems in one. Okay? So the next thing we're going to do is, I want you to look at that. We're going to first solve this inequality. And in a slightly different color, we're going to solve, secondly, this inequality. So let me set the first one up. We're going to go 6 is less than x minus 6. That was my first one, right? And my second one looks like this section right here, which comes out to be x minus 6 is less than or equal to 8. We separated out the two problems because they're kind of mixed in there. Okay, now what we're going to do is we're going to treat the inequality sign as an equal sign, and we're going to isolate the variable x, which means we're going to add 6 to this side plus 6 to this side gives me x is greater than 12. And now we're going to do the same thing to the other type of inequality, which now we're going to add 6 to this side and add 6 to this side, which now gives me x is less than 14, just like my student just called out. Okay, now we need to combine these two, okay? And we need to combine this because we need to show that x is greater than 12 and x is less than 14. And the way we do that is we put the x in the middle. We say x, or 12, is greater than x. Or sorry, x is less than x. 12 is less than x. And x is less than or equal to 14. Okay? Now that we have that, let's put it in the number line format just to show you what this looks like. Here's 10. Here's 12, 13, 14. Here's 14. In this case, this circle means it's greater than but not equal to, so it's an open circle. And if x is greater than 12, then you know it goes this direction. And the other one says that x is less than 14 or equal to 14, and you fill in your circle. And it goes, and everything in between here is what it looks like. So the way you read this is that x is greater than 12 and less than or equal to 14, and you would actually write that out in words for this kind of problem. Okay, this video is going to be a bit longer, so we have to separate this out. We have to try to isolate the variable x, like one of my students just said. The way we do this on this left-hand side is we add 5 to this side, add 5 to this side, which gives me 6x is less than 5, and 7 is 12. Then I divide both sides by 6. Divide both sides by 6. The 6's cancel out. Gives me x is less than 2 on this side. Or, in this case, I now need to subtract 1 from this side to isolate the variable x, minus 1 on this side, which now gives me 8x is greater than 24. Do that correctly. Divide this side by 8, divide this side by 8, and now becomes x is greater than 3. Okay, so the answer is x is less than 2 or x is greater than 3. Let's do our number line right here where I have the number 1, 2, and 3. Now, if I put this here, I have x is less than 2. I put a circle here, and I squiggle everything with an arrow that direction because it's all the numbers less than 2. And then I put another one here, and I squiggle the other direction, and x is greater than 3. So the OR statement states that basically there is a gap. There's a gap in between right here. And so that there's no overlap between them. Now there could also be an area of overlap sometimes, but that gets later on in the chapter. But that's what that means. This is the last example in this unit. It's along a bunch of examples. Here's what you need to remember. That whenever you multiply or divide across the inequality sign, which in this case is here or here, except I shouldn't have underlined it because that means equal to, right? Duh. Okay? With a negative number, when you divide or multiply across it with a negative number, you have to switch the direction of the sign. It has to go to a whole other direction. So let's first start by treating this like we did the last time as two separate problems. Here is one problem right here that we're going to copy down. And in purple, here's the other problem we're going to copy down. Now notice that I only copied it to the inequality sign. My student just asked that question, so I go negative 3 is less than negative 1 minus 2x. That's the one in red. And the other one is negative 1 minus 2x is less than 5. That's the other one that I copied down. These are two different, you treat them as two separate equations and you combine them back at the end. So let's get rid of this negative 1 on this side. That gives me a plus 1 on that side, which now gives me a negative 2 divided by a negative 2x. How do I get rid of this negative 2 now? I divide by negative 2. Exactly. So as I divide by a negative 2, and now here's my little trick is, the minute I cross that line, the instant I cross, I change my sign. I'm going to change my sign right now because I'm crossing it by a negative 2. And that way I don't forget it. Because I always used to forget this as a kid. It used to drive me nuts to get a dumb problem wrong. That's so easy because I forgot to change the sign. Let's go to this one on this side. Plus 1 gives me a negative 2x. Sign stays the same because it's a positive number. Sorry, and it's 6. And not only is it the same because it's a positive number, but it's also addition, subtraction, not a division of a negative number. And that's the only thing that makes it change its direction, is division or multiplication of a negative number. So in this case, in order to get rid of this negative 2, I have to divide by a negative 2. I divide by a negative 2 on this side. And this becomes, oh, I got to change my sign. You're right. See, I would have forgotten it right away. X is negative 3. So this needs to be rewritten as 1 is greater than x, and x is greater than negative 3. And let me extend my page a little bit. I'm going to draw my number line, and let's see how this looks, where you have this kind of inequality. If I have the number 1 here, 0, negative 1, negative 2, negative 3. I have x is, let me read it from the x sign. X is greater than a negative 3, open circle. X is greater than a negative 3, yeah. And you read it from the x, and x is less than 1, so it all goes this direction and this direction, and it needs that everything in between. Any questions?